All right, Algebra 2, welcome to Lesson 6.3 on geometric sequences. This is a warm-up over Section 6.2. Go ahead and pause it, and we will go over the answers. Number 10, x equals 9. Number 14 here, y equals -4. Remember, changing bases. This would be 5 to the third. Here I would use 2 to the third and 2 to the fourth. Number 16 was basically on 6.1 about writing an exponential function. Initial value of 6.4, growth rate of 2.5. Number 21, $16,755.63. And then inequalities, number 25, b is greater than 1/5. And number 27, d is greater than or equal to -1. Okay, previously we've determined whether a sequence is geometric. That might not be true, that's from the slide, but we're going to use geometric sequences and find sums of geometric series. So some new vocabulary. First of all, a geometric sequence. So a sequence is a list of numbers that follow a pattern. A geometric sequence is where you are either multiplying or dividing by the same number each time as you go up the list. The nth term, a sub n, the any term, you can think of that as, of a geometric sequence is the first term times the common ratio to the n-1 power. So if you want to find any term, you just need the first term and you multiply by the ratio, which is what it is you're multiplying by every time, and you do that n-1 times. So if you're looking for the 10th term, you take the ratio times the first term to the 9th power. Geometric mean is the terms between two non-consecutive terms of a geometric sequence. The common ratio can be used to find the geometric means. And a geometric series is the sum of a sequence. So when you're adding together all the terms of a list, that's called a series. The sum of the first n terms is denoted S sub n. And you can use some formulas to find partial sums or the first sums of a geometric sequence. So, again, the nth term of a geometric sequence is a very important formula in this section. You can find any term, the general term, by doing the first term times the ratio to the n-1 power. So, find the sixth term of a geometric sequence in which the first term is -3 and the ratio is -2. Well, if we apply the formula, the first term is -3, the ratio is -2, notice that's in parentheses, and we're looking for the sixth term, so we do the 6 minus 1 power. We can then calculate that using a calculator or using our math skills, and we end up with the sixth term being 96. It's very helpful if you want to find a term that's way down the line. Which is the fifth term of a geometric sequence, which has a first term of 6 and a ratio of 2. So you would do 6 times 2 to the fourth, or 6 times 16, and 96. Write an equation for the nth term. So write an equation for the nth term of the sequence below. What do we need to know? We need to know the first term, which is 5. We also need to know the ratio. What are we multiplying by every time? If you want to know the ratio, just divide any two consecutive terms. 10 divided by 5 is 2. 20 divided by 10 is 2. 40 divided by 20 is 2. So therefore, we know the ratio is 2. And then we can substitute first term times 2 to the n-1 power, and that is the general formula that we can use then to find any term. Write an equation for the nth term here. Now here we have the fifth term is 4, but the ratio is 3. So what are we missing? We're missing the first term. We have to find the first term. So what we're going to do is we're going to squeeze that general formula into here. So we're going to take the general formula. We know that 4 is equal to the fifth term. So that would be the first term times the ratio of 3 to the 5 minus 1 power, or 3 to the fourth power. So we have 4 equals a sub 1, the first term, times 81. So if we divide by 81, that gives us our first term, 4 over 81. So now we can write the equation. We know the first term is 4 over 81. We know the ratio is 3 to the n minus 1 power. And that's our formula. Even though it looks a little ugly, that will get us to that particular sequence. Okay, see if you can find this one. Letter C, first term is 3, ratio is 5. And first term ends up being 6, and the ratio is 2. So we're going to find three geometric means between 3.12 and 49.92. Since there are three terms between the first and the last term, there are 3 plus 2, or 5 total terms. So that means n equals 5. So we're going to find r using our formula for the nth term. So 49.92 equals 3.12 times r to the, we'll just call it the fourth power. If we divide 49.92 by 3.12, we end up with exactly 16. And if we take the fourth root of 16, we get plus or minus 2. So we can use r to find the three geometric series. There are two possible common ratios. So there are two possible sets of geometric means. You use each value of r to find the geometric mean. So here's the two values of r. So the second term would be 6.24 if we're using positive 2, negative 6.24 if we're using negative 2, 12.48 positive 2, 12.48 with negative 2, 24.96 or negative 24.96. So those are the three geometric means, 6.24, 12.48, and 24.96, or negative 6.24, 12.48, and negative 24.96. So find the three geometric means between 12 and 0.75. Again, there's those two numbers plus three geometric means, so that's 5. And that is letter A. Okay, so now we're going to look at the partial sum of a geometric series. So now we're going to start adding these lists of numbers. If you're given the first term and the number of terms, the sum is equal to the first term minus the first term times the ratio to the nth power over 1 minus the ratio. If you know the first term and the last term, it's just the first term minus the last term times the ratio over 1 minus the ratio. Of course, the ratio can't equal 1 because that's just repeated addition, and that would make you divide by 0. So Julian's band sees a concert. He posts the link for the band's website on his social network page. 5 of his friends repost the link, then 5 of their friends repost the link, and so on. If this pattern continues, how many people reposted the link after the 6th round? You see how this produces a geometric sequence, because we would have 5, and then 5 more of 25, and then 5 more of 125, and so on and so forth. So using one of those sum formulas, we do not know the last term, but we know the first term times the ratio to the nth power. So we can do 5 minus first term of 5 times the ratio of 5 to the 6th power over 1 minus the ratio of 5. And when we calculate, we end up with 19,530. So that means there would be 19,530 emails sent after 6 rounds. Here's a problem for you to try, guided practice. Go ahead and pause it. Okay, and the correct answer is letter D, 3,279 people. And then we have sigma notation. So this is a little bit different here. This says the sum. This symbol right here means the sum from n equals 1 to 12. So that means we're going from the first number to the 12th number of 3 times 2 to the n minus 1 power. So that means we're going to do 3 times 2 to the 1 minus 1, then 2 minus 1, then 3 minus 1, all the way till we get to 12 minus 1. But this is a geometric series, so we can use the formula. We know that the first term is 3. We know that the ratio is 2 based on the formula here. The base of the exponential function is r, so r equals 2. There are 12 terms, so n equals 12. So we can just use our sum formula. 3 times 1 minus 2 to the 12th power over 1 minus 2 ends up with a sum of 12,285. You can also use your calculator to evaluate those sigma notations as well. So we can find the terms by replacing with all the way up to 12, then add. So we can do, 3 times 2 to the 1 minus 1, 2 minus 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if you add those all together, you actually end up with the same 12,285. So you need to decide, is it easier just to add it all out, or is it easier to go back and use a formula to get it? And either way is fine. Okay, give this one a try. Might be easier just to write out since there's only 4 terms from 1 to 4. And the correct answer is 200. You may need a little bit more assistance on the geometric mean and the sigma notation as in this chapter. Please refer to the notes and also the additional videos that are linked in the packet that is assigned on Teams. So finding the first term of a series. So we need to find the first term. We know the sum of the first 8 terms is 765. We know there's 8 terms, and we know the ratio is 2. So if we set up the formula for finding the sum, we have everything but a sub 1. So we can substitute, we can simplify, and then we can solve by reducing and dividing. So we get the first term is equal to 3. One for you to try. B is 1, or the first term is 1. And that completes lesson 6.3. Whenever you are looking at 6.3, we're looking at the warm-up, the band's warm-up. Think of this as a geometric series. When they talk about arithmetic sequence, looks like arithmetic gets pronounced arithmetic in this situation. An arithmetic sequence is one where you add or subtract the same number every time. A geometric one is where you multiply or divide each time. A geometric sequence has a common ratio. An arithmetic sequence has a common difference. So then here's some more examples similar to what we did with finding the nth term and so on and so forth, finding specific terms. Some more examples, and then here are the exercises along with a few word problems and an exit slip on the vacuums. And then there's enrichment. You do not have to do the enrichment, and that will conclude 6.3, and then we'll do 6.4 shortly. I hope all is well. Have a good one. See you soon.